Alright guys, let me give you a quick overview of the registers for the GPIO. But first I'm going to show you basically what our end product is going to be. And it's going to be, you're going to end up at the end of this, I guess, series of tutorials with basically two files. Here I've named them Hardware Abstraction Layer GPIO. You're going to have a .h file and a .c file. Your header is going to have obviously defined statements and variables and things like that used, prototypes for your functions. And as you can see, we have a total of 3, 5, 8 functions used in the entire driver for the GPIO. And this includes implementation for interrupts, so it's really not that difficult. Um, but it will build on itself. That's why we're doing the GPIO first, because obviously to use I squared C or U or the UARTs, etc., you need the GPIO. Your .c file will end up looking like this. It's again, you have some variables, you have your functions for all your pins and all this stuff. And I've thought about this, and I don't think I'm gonna post this code to give out, just because I know I've seen tutorials where they say, "Oh, the code is available here," and I don't watch it, and I go and I just start looking through the libraries, and I don't understand anything that I'm doing. So I won't post it so that you can actually go ahead and follow the series and type it out yourself so that you can learn it. Okay? So that being said, let's go now and look at the data sheet and get familiar with some of the registers for the GPIO. These are our clocks. Okay, yeah, these are. So you're gonna you can open up your data sheet for the STM32F103C8. Even though it's not called this, it's called RM0008, which is the reference manual. So if you go into your section for GPIOs, and you can read all this on your own time, I suppose. It gives you a brief idea of how everything works. The registers. Let's start with the registers. Here we go. You have control high. This is control low, excuse me. And you have another port called, register called control high. I'm sorry, not control, configuration. So this is your port configuration register low and configuration register high. Now these ports are identical in, I keep calling them ports. These registers are identical in function. The difference is that this first register will configure pins 0 through 7, and the high register will configure pins 8 to 15. Okay, that being said, I'm going to show you just the functional, I guess, description of the low register, and you can assume it's identical for the high register. Now, if you see here, let me get my pen drawing thing here, and let's plug in my tablet. Uh, if you see, come on, tablet, hold on. My tablet needs to start working. Okay, there it is. So as you can see here, this register is 32 bits long. It's from 0 to 31. Okay. You have, and it's divided into sections of 2. One section of 2 bits is called mode 0. The next section of 2 bits is called configure 0. The following one is called mode 1, configure 1, mode 2, configure 2, etc., etc. The zeros, the 1, the 2, all of that denotes the pin that it's going to configure or modify. So these four pins right here. So basically these four, not pins, these four bits, as you can see, they're denoted mode 0 and configure 0. That means they're going to configure the mode for pin 0. Likewise, this configure 1 and mode 1 will configure the pins for pin 1. That being said, you'll notice that we only, with that, I guess behind that logic, we only have room to configure 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. So that's why we have the low register, which will configure pins from 0 to 7, and thus the high register. So that's why it's divided like that, because each pin takes up 4 bits to configure. So how do we configure it? I'm not going to get into super detail, but basically, for example, if you're going to configure pin 0, you're going to go to the mode bits, and these are your options to configure that. If you put a 00 there, you'll set that pin into input mode. If you put a 11 there, you're going to set it into output mode at a 50 megahertz max speed. Okay, now, so basically this comes with that. Now when this is when you set this to either of these 3 bits in output mode, then you have to configure when you configure this here, these are the next 2 bits for that same pin, the configuration bits, then you have to go to this right here. Okay, because this is when it's in output mode. So when you configure it in output mode, these options will apply in these 2 bits. So if you want it to be output mode at 50 megahertz, you put a 1 here. If you want it to be furthermore as a general purpose output or alternate function output, you know what I mean? So you can set it as output, but then what type of output? Do you want a general purpose output, push, pull, open, drain, or alternate function? And I will describe what alternate function is, I guess, later on. So you set the mode, output or input, and then you decide what type of output or input. So again, if you wanted, let's say, not to configure this as an input, you would put a, let's change colors just for fun. So if you wanted to configure that same pin now as an input, you put a 00 here, but then these options no longer apply because it's an input. So then the options that apply now are these. So now over here, now on these 2 bits, okay, these are your options. Because for the other one, I should have drawn it. For this one, when it was in output mode, you put those 2 options here. But now that it's in input mode, these options apply. Do you want it to be an analog input, a floating input, input with pull up and pull down resistors? Okay. So again, I hope that makes sense. And if it doesn't, don't worry about it. We will definitely get into the a better explanation later on when it well, actually probably in the next video when we actually have to program it. Okay. Now, next register. Okay, so that's like I said, the high and the low have the same exact description. It's just with the high register, you're configuring, as you can see, mode 8, mode 9, 10, 11, so all the way up to 15. So the following register is the IDR, the input data register, and this is straightforward. This is your input read register. Basically, if you're coming from the Arduino world, when you do a digital read, it's similar. Basically, it's exactly the same. You're gonna when your pin is set as an input, it's because there's outside circuitry, either inputting some sort of signal or pulses or something on it, and you're gonna read. So when you want to read, let's say if you have pin 7 as an input and you want to read the input, you would read this register at pin 7 right here, or value 7, bit 7, and the bit mapping for this is it's 1 to 1. Bit 0 is pin 0, bit 1 is pin 1, bit 2 is pin 2, etc., etc. So that's the input data register, which is basically going to be your digital read or analog read, etc. It's just this is where you're going to read from. Output data register, this is where you're going to set your pins high. So if you want pin 12 to be high, you're going to write a 1 into this bit right here at this register. Okay, pretty straightforward stuff. We're going to skip this one for now. I'm going to explain it right after the next one. This register is where you're going to set pins low. Again, if you want, let's say, pin 12 to be low, you would write a 1 here, not a 0. Okay, a 0 takes no action. This is your low, your reset register. Whenever you write a 1 into any of these bits, it sets the corresponding pin low. So it's like you're saying, yes, set 12 low, you know? So you write a 1 and it will set pin 12 low. So this is your reset register. Now, you might think, well, that's kind of weird, separate registers to, just write things high and low. Yes, that is weird. But you have your bit set and reset register. Now, this register itself can set or reset pins for you. And the beauty about this is that it's atomic. In other words, if you're coming again from the Arduino world, you know that well, if all you did was use the functions like digital write high, digital write low, then you probably don't know this. But in reality, when you write like digital write high, what goes on behind the scenes is that there's a port and it's ORing it with a 1 shifted into, let's say, pin 9, 9. That's what's happening behind the scenes. Okay, there's a port, it's ORing it with a 1 and it's shifting it the number of places that corresponds with your pin. The problem with this is this right here. This ORing, it's a bitwise operation. So there's comparing going on. There's a mask and it compares it to that mask and then shifts the result and etc. etc. The point is that with any time you have atomic writing, there's no ORing. There's just equals. So if you wanted port A pin 9 to be shifted high, you would just say port A equals 1 shifted to the 9. To the ninth bit. There's no ORing, there's no comparison, and it's much faster. And that's what this register allows you to do. Allows you to set the pins high or low with an equal without ORing it, because you know that if you don't OR it on any other regular register, you end up clearing the whole register except the bit that you want. So that's not really good behavior. So, and the way this works, again, we'll get to it when it's time to program it, but very quickly here, these bottom 15 bits, again, I probably should have mentioned this earlier. This is my third time making the video. I always exceed the time limit that I want. The GPIO, the pins for this microcontroller, there's 15 pins, and you have ports A through G, okay? And each of those ports has 15 pins. So here you can set from this bottom set of 15 bits is used to set the pin. So these used to set the pin high. As you can see, BS, BS, BS. It means bit set. Bit set is equivalent to being high. And then the top 15 bits will set the same bits, but will reset them. Okay, so you can see how it says BR. Quick example: if you want to turn pin 9 high, you would write a 1 over here. Okay, what the hell was that? Okay, I'm writing all over the place now. So yeah, if you wanted to set pin 9 high, you would write 1 over here. If you wanted to reset pin 9, in other words, drive it low, you would write a 9 over here. As you can see, they're right above each other. Now, what does this mean? This means that uh, from here all the way up to here, it's 16 bits. Okay, now how does that come into play? Basically, as you can see right here, it's bit 0 is pin 0, bit 1 is pin 1, bit 2 is pin 2. The mapping is straightforward. If you want to set pin 14 high, you go to bit 14. You get it? But how are you going to remember this? Okay, bit 14 is 30, bit 13 is 29. Well, you don't have to remember that. All you have to know is that you take your pin number, whatever it is that you're using, and that when you want to reset it, all you have to do is add 16 to it. For example, just take bit 14 here. If you want to set pin 14, if you want to set it low, all you have to do is let's just call this port A. Port A equals a 1 shifted where to what pin? Well, I want to set it low. What pin do I want to set low? Well, I want to set pin 14 low. Okay, but I don't remember the exact number of the top 15 that corresponds to pin 14. Doesn't matter because they're all going to be 16 bits from each other. Okay, so if this were port A and you shifted a 1 into 14 plus 16, you would get 30, and it would actually be the correct spot to set this one a 1 here, which will reset that pin. Okay, and that'll work for any of these bits because they're all 16 bits from each other. Again, once we start coding this, it should make more sense, and I hope I can make sense. So that's your bit set reset register. Your final register here for the general purpose input output is your lock register. What this does is when you first you have to type a certain sequence that it's given somewhere else in the data sheet onto this. You have to write a certain sequence onto this pin, which is basically a bunch of random stuff, and then you can use this register, let's say, to lock pin 12. That means you can't configure it. Once you lock a pin, it means that you can set it high later in your code and it won't do it because it's locked. Now I don't understand the purpose of this, because if you don't want a pin to be written to, then just don't write to it. But I don't know. Anyways, I've never used this, so I'm not even sure I'm gonna go over that. And since this register right here is used to set and reset, I've never used this register, the ODR, the output data, or the reset register, because this does them both. So why bother? Another thing to note is the alternate function register. This register is it's part of the pins because you have to set the pins to alternate functions. So if you want your pins to be used as USART, you would this is the register that you would use to get what pins are USART or to remap them to different pins, and we'll get to that. For the time being, we're going to use this alternate function registers just for the just for this just to map our what do you call it, our interrupts. Okay, and I'll explain that when we get to that, which will be the last section of the GPIO. So, just to, I guess, reiterate what I forgot to mention earlier was that the microcontroller, it has 15 pins per register, I mean per port, and you have several ports. Again, the ports are from A through G, but you have to keep in mind if you have if your microcontroller, your specific chip on your board, only has 48 pins, you obviously are not going to have all ports A through G. If you let me Google here quick. What is this STM32 F103 C8 pinout? If you Google the pinout of your microcontroller, you can see that, for example, I have the 48 pin package. As you can see here, if this ever loads, nope, can't get that one. Um, is this a 48? Yeah. So as you can see, here's a pinout of my specific the chip I have on my microcontroller board, and this is the 48 pin. So I do not have all those ports from A through G because obviously there isn't enough room. I can see port A, port B, and about two or three about port C, and that's about it. I only have two ports. I only have like 30 something 30 something actual pins that I can use, and the rest are for crystals and powers and ground. Okay, so keep that in mind, that just because you have all these ports available to program, they're not necessarily on your chip. So don't try to use obviously port G if you only have a 48 pin package. Another thing to note is, let me go here and try to find this. Okay, right here. These pins PA 13, 14, 15, and PB4 and 3, these pins are for your JTAG and your software debug. Okay, this is, you kind of want to stay away from these pins just because if you're using the ST link like I showed you, that I got from eBay to program the chip, is using these two pins right here to program your chip. Now if you're connecting LEDs or anything on it and it's blinking or it's doing something and then you try to program it, it's gonna not work exactly. It's not supposed to interfere, but it can, and maybe you can fry something. Who knows what, what I'm saying is just stay away from using these pins right here as to play around with, just because these are the ones that your ST Link is going to use to program it. So just avoid these pins if you can. And yeah, that's a basic summary of the GPIO and what we're going to be doing in this course. And if I missed anything, I'll probably write it up in the written version of this. All right, guys, take care.